All right. So yeah, today with us for our presentation, we have Dave Heemstra, who has his certified lighting controls professional designation as well as certified technical representative. He's a project manager with Intelligent Integrated Systems, and he's over at Smith and Anderson right now. So Dave Heemstra has worked in the lighting and automation industry for nearly 10 years and has been involved in projects in just about every sector. Having worked on such a broad portfolio, including net zero and carbon neutral buildings, he's developed a comprehensive knowledge of the interactions the various building systems can have and the opportunities those integrations have for improving building operations and user experiences. Over the years, he has become an educator and resource to the marketplace and has now recently joined the Intelligent Integrated Systems team at Smith and Anderson to further systems design and integration within the Alberta market. He is always excited to discuss upcoming technology and innovations and share his passion for building infrastructure design. So yeah, without further ado, I'll hand it over to Dave. We're really looking forward to your presentation today. So yeah,
Thanks very much.
gonna be
Appreciate
good.
it. Basically, that whole description just says I'm a big nerd. So please enjoy as I talk about all things technical here. Um, so I know I see a bunch of familiar faces, some unfamiliar faces. I was in the lighting agency world for a number of years here, working in the lighting automation side. But with Smith and Anderson, this intelligent integrated systems team is basically focused on smart building technology and coordination between multiple disciplines. We're going to kind of dive into lighting control specifically, but it's really important to understand that to deploy a smart building, by definition, smart building, it's really difficult and complicated because there's so many divisions of the spec that get touched. There's so many procurement challenges, and there's so many challenges in getting everyone talking the right language to the right people and actually coming out with the end result that the ownership or the client or the developer was actually expecting. So basically, Smith and Anderson has built this team up of people that are somewhat specialists in a few things, but kind of know a lot about everything to try to kind of bring it all together and herd cats, so to speak, in terms of intelligent buildings. So today I'm going to talk about lighting control specifically. And we'll talk briefly, because I always do this at the beginning of all my presentations. And for all of you who have seen one before, you probably recognize these 6 strategies, but I like to make sure we're all on the same page. So we talk about our core lighting control strategies. These are the strategies that just about every lighting control system, every lighting code is going to be looking for in the building operations. So we've got our basic occupancy-based control. Put an occupancy sensor in the space, it detects motion, and it holds the lighting on, turns it on. After time delay, it may turn it off. So we're using this all the time, everywhere. And in NECB and just about every energy code, these are pretty much a staple of any lighting controls. We're doing our time scheduling as well. Again, time schedule, we've had timers and contactors for decades now in buildings. So we're doing a little bit more in terms of time scheduling, where we're layering strategies. We may have time schedules that activate during normal hours, and then after hours, they move into occupancy mode. So we can kind of start to layer the lighting control strategies and not just have an on-off command with an override switch somewhere to hold it over for 2 hours or something like that. So we also move into task tuning. This is something that is almost never touched, but really should be looked at. And it's something that, especially if you're working into a carbon neutral or net zero type of building where energy efficiency is vital, it's very important to be able to set our maximum minimum outputs for our fixtures. And with just about every fixture dimmable and many code requirements requiring dimming in the space, we can set those maximum brightness levels for those fixtures and save a little bit of additional energy. With LED fixtures, it's almost 1-to-1 in terms of energy savings. So you dim that fixture down by 10%, you're going to use about 10% less energy for that fixture. So if we can cap off the maximum output value and give ourselves that extra little bit of room, it also helps with lumen depreciation, because in 10 years, as things start to dim down a little bit, we have that room to bump that back up and get back to some of those higher light levels. Daylight harvesting is the idea that we're going to put in a sensor into the space, and we're going to measure the amount of natural daylight coming in or the overall brightness of the space. And then we're going to adjust our artificial lighting based on that natural light. So again, part of most energy codes right now, it's kind of, it doesn't give us a lot of bang for a buck. I would expect to see lighting controls in some of the future energy codes starting to step away from this as well, just because it's very rarely calibrated properly, it's very rarely programmed properly, and more often than not, it's the first thing that gets deactivated in the lighting control system. So it's included in a lot of spaces, but we're talking usually 6 to 7% energy savings overall in your building of your lighting load. So we're not talking about a lot of energy. It's just something we kind of have to do. Personal control is where we're giving the manual control to the occupant in the space. Something that we had moved away from for a little while, where everyone just had lights on and off. But now we're looking at things like vacancy control, where when you walk into the space, if there's an occupancy sensor, it's not going to turn the lighting automatically on. You have to turn it on yourself. Further to that, you add dimming, and now the occupant can actually set the brightness level. I've done many systems and looked at the data from quite a few different buildings, and generally, as soon as you give someone the ability to control their lighting and especially dim it down, they typically dim it down by quite a bit more than anyone's expecting. I'd say the average occupant likes lighting kind of down in the 60% range, especially if there's windows and a lot of natural light. You start to find a lot of energy savings just by giving that person the ability to control their lighting. Still use your occupancy sensor or your vacancy sensor to make sure that lighting turns off, but you get a lot of energy savings. And then lastly, this variable load shedding is the ability that we can, have a maximum threshold of energy usage in the building, and we're going to start cutting loads as much as we can if we're nearing that threshold. Very important in the net zero world of things, where you need to be able to manage your energy usage and not go over certain thresholds that are important for that building. Still not seeing a lot of that in Alberta, except for those really special projects that we've done quite a bit of work on. So let's kind of define what an intelligent building is. So we're going to kind of get into a bit of semantics, but it is verbiage that's really important to understand. A lot of people call them smart buildings. It's a buzzword everyone's using. We've kind of identified or kind of tried to divide it into smart and intelligent. So smart is something that's programmed so as to be capable of some independent action. So this means that I can say, when this sensor sees motion, I'm going to do this with my system. We can tie it into other systems like HVAC or, or security or anything like that. And we are, essentially having a connected, integrated, smart system, but it's not going to go beyond those preset triggers. We've kind of defined what it's going to do, and that's how it's going to always respond. An intelligent building is where we're going to start taking that data and start to adjust the system based on the trends that are happening in that building. Let's use a storage closet. We put an occupancy sensor in there. It gets left at 20-minute time delay. Someone walks in and walks out in 2 minutes. We're using a lot of energy that we don't need because those other 18 minutes aren't used. So an intelligent system would then have a time delay that adjusts over time based on that usage. So after a little while, that sensor has figured out, hey, most people are only spending 2 to 4 minutes in here. So we're going to set a time delay of 4 minutes and get that energy savings. So the goal, the dream is intelligent. We're doing a lot more smart than people realize, but really ultimately a lot of the use cases that we're seeing clients ask for is getting into that intelligent range. So how do we kind of look at that? So first of all, we got to understand why clients are looking for building intelligence. What are the motivating factors here? We can enhance the user's experiences. We could talk about operational costs, but by and large, the motivation has to always come down to, is it actually useful for the owner and then for the occupants? So there is a lot of cool factor things out there, things where it's, a manufacturer will say, hey, we can do this. And it sounds pretty great. We can integrate everything, but is it really useful to the end occupant? Oftentimes you kind of got to wade through some of that. And so we want to look at what type of building it is and how is that going to affect the operational side of things. And so then there may be certain use cases that are really important and others that make no sense at all. And that extra cost and that extra systems coordination is unnecessary. We also include things like mitigating operational and cyber risks. Right now, a lot of the way, and we'll talk a little bit more in a couple slides about this, but a lot of the ways that we're integrating is everyone's got their own siloed infrastructure, their own network infrastructure. And then somewhere in a server room, we've got all the different system servers and we're integrating at that point. And what's happening now is we're usually giving internet to those different servers. We're exposing all of those systems. It's actually less secure than if everything was sitting on one network that can be managed by the IT department or IT company that's managing that infrastructure. So if we can build a converged building network, something that everything can ride on rather than its own individual silos, we can make it more secure, and we can also reduce the overall infrastructure required. We'll talk a little bit more about that here coming up. But what I want to focus on is the specific use cases that really have to do with lighting and lighting control, the ones that we can actually impact. We have a list of 50, 60 different use cases for intelligent buildings. So, I want someone to be able to have an app that they can turn on, music, their lighting, and their HVAC in their suite. That's a use case. So what kind of use cases do we have that lighting controls would actually have an impact on, or is required to have some sort of intelligence? The first is, and probably the most important, is this single pane of glass, the SPOG. You'll see this the more and more you talk about intelligent buildings, the more you talk to clients who are talking about smart buildings. This single pane of glass is the ultimate goal. It's the idea of a universal remote. What most, and this is usually probably geared towards the operations teams, but what they're trying to do is make it so that I can make one global system change and affect multiple systems. So the example I'll use is a time schedule for an occupant or a tenant. Tenant wants to stay late that night and they say, I want an extension on the time schedule. And that's going to impact the security system. That's going to impact the AV system potentially. Some of them have triggers in them. It's going to impact the lighting control. It's going to impact the HVAC in that room, in that floor. There's a lot of different bits and pieces that I'll have to now be extended. And traditionally you have, 5 different monitors. You go to each one, log in, change the time schedule and go. So ultimately the idea is that we want a building, or we want a system that we can very easily go in and say, okay, I'm extending the time schedule by 4 hours, and everything else is done in the background. That's the goal. That's where they're looking to get that. That's that operational efficiency that we see everyone kind of striving for. It's not impossible to hit, and it's actually quite simple in a lot of cases, but it does take a bit of coordination. Another very common use case is occupancy detection and the HVAC integration. So can we have the occupancy sensor that we have on our lighting control system be able to activate the HVAC? You'll start to find, especially when we talk about the Internet of Things or IoT, everyone's got a sensor. And HVAC systems have occupancy sensors. Lighting controls has occupancy sensors. Now there's IoT companies that are developing their own little sensors that have occupancy sensors in as part of the kind of the overall suite. So can these sensors from our lighting control system actually perform some of the functions? So we're not having this ceiling acne on the ceiling with so many sensors because every system has their own sensor. That's a huge use case, and it is heavily underutilized right now. Occupancy sensors, this dry contact to a VAV box in the HVAC system, great. that's really easy, and we're doing that. But going to that next level and actually taking the data from that occupancy sensor, analyzing it, having it feed into the security system, and actually have the security system make decisions based on that, those are the level of integrations we're talking about getting to when we talk about this use case. There's also a few other kind of use cases here. Further to that single pane of glass, I already kind of talked about this after hours tenant services, being able to extend times and everything like that. I say occupancy awareness and restriction. What this means is, can I tell when a boardroom is occupied? Can I tell when a fitness center or an amenity is busy? And can I feed that information back to an occupant? A lot of residential towers are looking at this kind of thing where, if someone is planning to go down to the gym, they can pop open their app and they can see how busy is the gym right now. Is there a lot of machines used? And then they don't have to get down the stairs and get to the gym and find out that, yeah, it's packed full and they're going to have to come back later. So just being able to see at a glance if this is working. In meeting rooms, if you have, I know a lot of universities or colleges have a large number of rooms that get booked, and there's a lot of problems with loitering or with spaces being block booked for weeks on end that without anyone ever using them, they just want to make sure they have it blocked off just in case. So you can actually tie into the booking system with the occupancy awareness and determine, is that space actually being used when it's booked? And if it isn't being used when it's booked, then that person who's doing the booking can be talked to, and they can start moving them around, and you can make smarter decisions and better utilize the booking system in the space. Presentation in AV, this is fairly straightforward, and everyone's been doing it for a while. Classrooms, boardrooms, being able to dim the lights down, have the projector screen come down and the shading come down, and have that single button press is something that we're seeing done very often now. It's not an uncommon thing, but it is a use case that does involve our lighting controls. And then lastly, of course, energy consumption. When we're talking about systems in buildings where we are really focused on energy savings, so net zero, carbon neutral, anything like that, or we have metering and sub-metering systems, how much or what can we take from the lighting control, and do we have enough data, or can we gather data from the lighting control system and maybe save ourselves on the metering system rather than sub-metering all of our lighting loads? Maybe we can pull the data from here and feed that into the metering system separately. So we're looking for efficiencies. When I talk about integrating systems, we're not just doing it for integration's sake. If we're doing that, then we haven't really thought through the use case, and we haven't really thought through whether this is a value to the client involved. We want to make something that's actually going to have a value to everyone. So the Converge building network, and this is kind of a critical part of the entire story when we talk about an intelligent building, and it's very important to understand how vital it is to making this high level of intelligence in a building. When you have multiple systems all kind of siloed in on their own infrastructure. So your HVAC system has one single comm network. Your lighting control has one single comm network, and everything goes to that main server room. What ends up happening is, first of all, it's very inefficient. You've got a lot of extra gear and a lot of extra hardware that is required to be maintained. There's many more failure points than you normally have in those spaces, and you also have a less secure network. I've gotten to know a few different IT departments very recently and found out that things like Cisco switches, where they have to pay on their service contracts or service fees to manage their telecoms with Cisco or Netgear or anything like that, the cost per switch to maintain these buildings is actually quite high. You can actually pay 5 times the cost of that original network switch over 5 years just in service fees. So if you have triple the number of switches in your space than you actually want, or than you actually need in this space, you're actually going to be costing that building a lot of money. Further to that, if we have everything on the same network, the communication is stronger. we can feed those direct linkages between systems, and we can have them talk in a way that they would not be able to talk through just a server level integration. We're having them actually talk from IP to IP. And that's very important when we want to talk about an efficient use of our smart systems. So let's talk a little bit about lighting controls technology that's out there right now, and how do we actually talk about this in a way that, let's be honest, budgets are not high right now. But we want to give that expansion ability. We want people to, be able to take what we've designed today and be able to apply smart building or intelligent building technologies down the road without it being a very complicated maneuver. So the first thing we always have to do, or we have to really consider, is do we need digital or do we need analog? So digital obviously has a lot of the ability to have that data, feed that data into other systems. Digital is going to be the way that intelligent controls is going to work, but we don't need digital everywhere. We have to think about these use cases. A use case, of all those use cases that were listed there, a washroom really didn't fit the bill. We don't have anything in a washroom other than we need the lights on automatically and we need to turn them off automatically. So it would be overkill to start talking about putting digital sensors into, say, a washroom, because we're not going to need that data probably in the next, unless someone comes up with some random use case for a washroom, but I don't think anyone's going to really buy into that anyway. So we can look at the spaces that we're using, that we've got in the building, and really focus in on where do we think there could be future use cases and where is it just not going to make a whole lot of sense. It's also important to know, do they have firmware and software updates readily available for those digital devices? It doesn't do us much good if it's a digital normal system, but doesn't have the ability to be reasonably upgraded. What communication protocol is being used? So LawnWorks, Modbus, if you see them, I know some clients still require them. Some cities still require them, but these are very outdated, and they're very much designed for HVAC, not for lighting control. So BACnet is still one of the more valuable. We need to make sure it's BACnet over IP, because IP means that it is a networkable integration. But ideally, even if it's BACnet today, does that technology, does that digital sensor or that digital system have the ability to use REST API or API? Now, for those of you not familiar with APIs, an API is essentially the best way to describe it is, I want to make my system and all its data open to anyone who wants to write a little piece of program that can gather that data and do something with it. So you talk about anyone who's written a smartphone app. They are using APIs. They're taking the data from the camera, from the push buttons, from the light sensor, from the gyroscope in the phone. They can take all that, it's free data to use from that device, and they can make it do weird, wonderful things. That's the idea behind an API. So when you talk about the single pane of glass and the ability to have everything kind of communicate, and you talk to these, larger companies now that are making these automation systems that can do all this, like Code Labs and Convergence and Siemens and everything, they're writing APIs. They are saying, I just want everything open. You give me all the data that you can give me. Here's all my points, and I'm going to write a piece of software. It's two directional. It gives us a lot of flexibility, and it gives the ability to perfectly and customize that operation for that building. So APIs are really the way that we're going to see these technologies going. And even if we're not connecting it up right now, does that system have that capability down the road, and how does it do that? This is kind of an important question. With the digital, is there a standalone option? We need to know that we can deploy this digital device, but without network infrastructure. We're trying to design a system that is good for today and workable within today's budget, but something that can be expanded down the road if it needs to be. So, we want to know, can it stand alone? Can it work on its own right now, but then can we upgrade it down the road? Can we connect it down the road into a networked infrastructure, use those APIs and actually do something intelligent with that system? There is a lot of most of the lighting control systems out there, the big ones, they are all doing this. You're starting to see a model coming out where they're working on kind of a tiered approach with the manufacturing. So you can start with your lower level or standalone option. You can upgrade to your building option and then enterprise level. But they have this tiered approach where you can jump from level to level after the installation as well. And that's one of the key things here. I don't want to have to buy the enterprise level now if I don't need it right now, but I need to know that I can get there with the lower level product line before, or for the building at hand. So kind of gives us that flexibility. So let's look at some basic devices. So we've got occupancy sensor switch, photo cell for daylight harvesting. When we talk about digital, they can be if they're going to be a digital device, they probably are going to go back to some sort of digital power pack controller of some sort, something like that. Every manufacturer now has something like this, but generally it's going to feed into something. It's like a converged point in each room or each space that you're going to be bringing everything to. So you're going to build these digital power packs into individual spaces. They're going to converge at that point. And then eventually they're going to go back to some sort of device hub or something that's going to kind of bring all of that together. Usually this often is proprietary, or the cabling it could be Cat5, it could be twisted pair, 4-pair, something specialized for them. But then usually from this point on, you're probably going to be trying to go Ethernet or some sort of networking. Now, for our low budgets and initial offering, or what we're talking about putting into a building, I want to stop here. I want to be able to stop at this room level and get that basic operation. The room's going to operate exactly how I want, but I want to make sure that down the road, when I want to network this back to some central head end or do that integration, that this connection is actually quite easy, and so in some cases, wireless might be the way to go. I don't see a strong value, and some of you might find this funny, but I don't see a very strong value in wireless sensors. They have batteries. There are certain installation applications that they do make sense for, but generally, especially in a new build or even in some tenant fit ups, you're going to be running wire. It's not a big deal to run that extra wire, and you limit the use of batteries by doing that. And operationally, it just starts to make a lot of sense. But going from here to here, wireless makes a lot of sense, especially if we're doing this connection 5 years from now. That's something that we want to make sure that we have the ability. Can these upgrade? Will they have firmware upgrades, and will they support them? And make sure that we can actually do that future upgrade. Now, every manufacturer has luminaire integrated fixture sensors and devices and everything, and everyone's going smart fixtures. I've always said there's a bit of a scale of economy here. In small scale, it doesn't make a lot of sense. Very small rooms, the added cost for a wireless fixture that's going to have all that devices in there and go back to some wireless device hub in small scale, the cost of it just doesn't make a lot of sense. And now we're not talking about a standalone system that can be future proofed. We're already deploying, really the enterprise level at that point. So if we need higher density of sensors, or if it's a large capital project, this does start to make sense when we have a large volume of space. But if we're doing a 5,000 square foot office, this is gonna add extra cost to the project, and we're never going to see the actual benefits from an intelligence standpoint or an integration standpoint, and we're really just going to be kind of adding an unnecessary level of integration that isn't really valuable there. And then of course from there we're going to go back to that converged network. So Ideally, when the building is being designed or whatever is being built, there is some sort of communications riser that's being put in or has already been put in. You might be surprised to find out, when you're talking to your client, a lot of buildings, aging infrastructure, have actually done a upgrade to fiber of their building backbones, generally because they were doing a security upgrade. Security systems tend to push or drive the upgrading of infrastructure to communications, just because they don't have another option. A newer security system requires certain amounts of bandwidth. It requires a certain amount of infrastructure. It kind of comes hand in hand. So you can find out very quickly if you're talking to the client and ask them, have you recently upgraded security or communications? Because oftentimes they'll have upgraded both. What that means, though, is if they've done it properly, they also have spare room on that infrastructure. It's right now probably exclusively a security riser, but that is going to be your backbone, your Converge building network that we can actually start to tie into without adding any more infrastructure for all of our lighting control or other systems. So in a lot of ways, that there's going to be efficiencies that with a few simple questions to the client, you can start to find out that there is some infrastructure involved, and this future use case may be able to very simply be done or very quickly be done in 2 to 3 years for very low cost, because it's a simple connect a couple wires up to into the comm room and then have some programming added on. So we've given the client value, in terms of what they can do now, but we know that also that they've got that infrastructure in place. So where do we need to future-proof? So we talked about those kind of use cases that you've seen. So meeting rooms, common areas, elevator lobbies, classrooms, lecture halls. These are all spaces that these use cases probably will hit. It makes a lot of sense when you have AV or you want to be able to do people counting or anything like that. Digital lighting controls is probably going to make a lot of sense, because that's where we're going to see more value when we start integrating systems. But if we go to spaces where we don't necessarily see a whole lot of future use cases for smart technology or intelligent integration, we can avoid that. We can go analog with our more traditional low voltage sensor in a power pack, or even a line voltage sensor in a lot of cases. And we're not going to be handcuffing the client. We're not going to be really, telling that client that, hey, probably down the road, you're going to have wanted to have digital controls in here because, we're going to be doing some fancy stuff, but you don't have it. These are pretty safe ways to go. And these are all the spaces that I listed here are all spaces that you've seen probably in NECB or ASHRAE, very similar to those. So, we can still meet all of our NECB or ASHRAE requirements in all these spaces without going digital. And we can save the cost, and we can be pretty confident that there's not going to be a lot of opportunity down the road that they'd be regretting that fact that it is an analog device or analog controls in there. Couple other just some considerations just to kind of keep in mind when you're vetting that lighting controls technology or looking at what you want to use. Security is the discussion. It always is, always will be. And it is something that IT departments and IT companies are always looking at. So we just need to make sure that the sanity check on that product, that they have a robust security policy in place, or that they have the built-in technology. Generally, most of these manufacturers are very proud of their security levels, so it doesn't take a lot of digging to find out if they've got the right protocols and they got the right encryption levels, but it's definitely worth asking. It's definitely worth gathering the documentation, and especially if we're talking about the future use cases, it might be important to have that brief discussion with IT just to understand that what their needs are, so that they can be comfortable to say, yeah, we can do that down the road. Wireless is there. I will say there's a war over wireless protocols right now, between Zigbee and Bluetooth as kind of the top ones, but you've got Wi-Fi, you've got 6LoWPAN, and Ocean, all of these different protocols kind of into the market. I'd love to say that there's one that's going to win over the other, but it's really hard to say. Zigbee has an inherent security level because, my cell phone has a Bluetooth radio. It doesn't have a Zigbee radio, so it's a lot less accessible. But Bluetooth is a lot more convenient, and they've, recently increased the standard, so you've got longer ranges. So some manufacturers are not even hedging their bets. They're putting both radios into their sensors, whether you know it or not. I know of some manufacturers that have Zigbee and Bluetooth in their sensors, so that if down the road it changes or everyone goes Bluetooth, well, then they're going to be able to go Bluetooth. So just something to keep in mind. Wireless, I find, is a technology that is more popular when the economy is strong, when we have higher budgets, and when everyone's kind of looking for higher end controls. In low budget and let's get this out quickly kind of applications, I think wireless doesn't seem to be hitting the mark as much, and it's an added level of complexity or uncertainty to a job that most people don't want to have because they don't have the budget or time to put into dealing with that. So something to definitely keep in mind. So the kind of what we really want to do is was always focus on the big picture. We're talking right now about lighting controls, we're talking about occupancy sensors, but we got to keep in mind that these are just one small element in the overall integration system or building systems. So and different owners are going to have different values right now. If you talk to a residential condominium tower, rentals, that sort of thing, they're probably going to be talking to you all about, or they're probably talking a lot about leak detection and climate control. Those are the big ones. Those are the money makers from a liability standpoint. Lighting control, they don't really think much of it. They're not really motivated by that. They're looking at, what's going to get my tenants in the door and what is going to keep them renting the space. Or in leak detection point of view, can I put in a leak sensor? I was actually talking to a client in Ottawa that is looking at leak detection sensors with automatic shutoff valves to remove the drain in the laundry rooms in each suite. The cost savings from doing that is actually quite huge, and the code actually allows it over there, at least. I don't know about here. I'm kind of curious to look into it, but they're looking at leak detection as being their number one system, and then integrating that into their operations system for alerts and monitoring. When we asked about things like lighting control, they said just throw dimmers on the wall. They were okay with it, right? So everyone's motivation is going to be different, and the building type is going to be different. So we need to look at where's the budget going to fit, and where does it make most sense for that client specifically to put the budget into, and what parts are going to be the less important. Going back to those use cases that we talked about, lighting control doesn't hit all of them, and there may be 30 different use cases that they're all going after, and only 5 of them have anything to do with lighting control. So it's going to become a smaller priority. So just something to keep in mind when we're talking about that. So we got to take a measured approach. We start low budget, we go to our high budget, and so we're going to use, at the low budget end, we're going to use expandable digital only where necessary. So really just kind of focus in on those spaces. If it's a small office floor plate, we're probably going to throw it maybe in the boardroom, right? We may put it into the open office space just because maybe the infrastructure is already there, or there's an existing lighting control panel that has digital elements to it. It's already able to do that, but we're going to really be selective with exactly where we think that there's going to be a value there. As we move up that budget run here, we're going to probably start using digital devices in some more expanded spots. Small offices it may make sense, especially for some of the VPs that may want that kind of app access, or some of those intelligent features that they're looking at. As we kind of move up, we're going to look at that network infrastructure. It's just the questions have to be asked, right? We're looking at, do you guys have any scope included already for network infrastructure additions, or if we're touching the comms riser because we're getting the internet service provider set up, or there's some work that needs to be done on the security, well, maybe that's an opportunity to add those extra fibers, or add a little, bolster that infrastructure just a little bit in preparation for future use cases with the lighting control. We may then keep moving up the budget. We may start roughing in, where we would actually put some of that infrastructure for networking. It could just be that, we've got cable tray up there and we're going to be planning that cable tray is going to be used for lighting control gear as well. It may just be leaving space in the telecom closet or the electrical closet where we will be able to put some of those consolidation points. But just start thinking about that infrastructure and looking at where maybe we want to, if there's a high motivation from the client that, down the road, they're going to really attack this kind of intelligence, well, then let's put a little bit of that money into the infrastructure. And then future, designing or upgrading the network to support future IoT. So like we're getting into what's that comms riser look like? How robust do we need it to be? We're probably talking about actual telecommunications scope on a project rather than just electrical. So we're probably expanding kind of beyond that. And then up to deploying fully networked lighting controls. Like I said, big, large capital projects and brand new buildings, we're probably already heading there because we're shooting for LEED or we're shooting for different certifications. There's a couple becoming very popular, like Wired Score, Smart Score, which are kind of like LEED, but for smart buildings. So we're going to be looking at, this networked lighting controls when we're looking at those kind of certifications. But I think the biggest takeaway here is that we want to consider those future use cases and only attack what we really think is going to be valuable. And it can be that, the client says, I'm not going to touch any of this in 10 years. I just want a space that works. All right, we know where their motivation is. We don't need to go too far. They may still want the fancy boardroom, so we're probably going to put some digital control for the AV and integration that way. But maybe that's as far as we need to go. We need to apply that necessary hardware, but we also consider the bigger picture. I like to say that if this building is 30, 40 years old, and this is part of a maintenance and kind of renewal plan, or they're just trying to kind of get boilers starting to work again, or something like that, chances are in the next 5 to 10 years, they're going to be focused on keeping that building running, less about, making it a AA, AAA class building for rental and that sort of thing. So, we can kind of temper our approaches there. In some cases, maybe, replacing some of the existing equipment, we can replace it with newer digital equipment to give that kind of foundation. But generally in those kind of cases, again, those buildings, we really want to just keep them running and make them last for another 10, 20, 30 years. And that's really going to be the focus. So then, we kind of take a measured approach with how we approach the lighting controls design in that space. So I know it was a lot of information, but I hope, you guys kind of took some value out of it. It's really, I will say this, everyone's talking about it. If your client themselves hasn't, mentioned it or talked about it, you can bet that corporate or the higher levels are talking about it. A lot of these companies, especially the large developers, are building smart technology roadmaps or design guidelines, or things that are going to be managed from a corporate level, but standards to be set for all of their future projects. I can't count already the number of times I've sat down with a client to, and just ask them, is there any requirements for your security system that have to do with integration to other systems? Is there a smart building plan? And the local project manager doesn't know, checks with corporate, finds out sure enough there is, or they're working on something. So it is a topic of conversation that is very constant, and everyone is talking about it. So it's not out of place to start asking those questions when we're talking about our designs. So I don't know if anyone has any questions or comments or anything like that.
Hey, Dave, I have a question. Great presentation, by the way.
Thank you.
The question I had is, what sorts of things do you look for in future expandability of products, and I guess what makes you more comfortable in specifying a product and saying to the client, like, yeah, we can likely expand this in 5 to 10 years?
What I really want to see is there's kind of two factors. First of all, if you go to that manufacturer's website and they've got a lot of talk about smart building technology or APIs or all, they're like really forward focused on that. It's a good sign that they've put the R&D into that product. They've put the time into that, and that is, they've identified that. If it's, if their marketing is really focused on just here's our next greatest occupancy sensor, then there's a good chance that they're not as forward thinking, or they're not focused as onto that some of that smarter technology. So that would be one of the things I'd be looking for. The other thing I really want to find out is, or I really look for is, how long have they been around? I know a lot of specs now we put into the verbiage to say, they've got to have been around for 10, 15 years, that sort of thing. Generally, that is a pretty safe indication. There's a lot of fly-by-night sensor companies now, especially with IoT. That is, because everyone's trying to jump on that bandwagon where, everyone sees the money on that's coming down the pipeline for smart building technologies. So we want to look at how long they've been around, because, ideally, if they've been around a long time and their marketing focus and their websites are all gearing towards smart building systems and everything else, then they've put the budget behind it, they've put the financing behind it, and they've been around long enough to know what they're doing and not just be kind of following the fad.
Great, thanks, Dave.
Yeah. Any other questions? Cool.
I do have one more. Sorry, I was just waiting to see before I stole it again. Is there a way, when you're talking to clients about IoT, do you have any strategies on helping them understand the difference between like commercial IoT versus the types of products that you get in your home?
Yeah, it's a big discussion, and it's actually what's feeding into the residential market, in terms of smart adding technology into suites, because people are coming in with the expectation of what they've seen in the smart home. I think the biggest discussion is, and I've had this on a couple, is that we need to ask the very pointed question: what you're doing in that home system, is it actually valuable to the end user? Sometimes it is, absolutely, and then it makes a lot of sense. And then we got to look at what's actually commercially available that's secure, because I hate to say it, but just about all of that home automation stuff is the least secure stuff you can possibly have. And that's what changes it from commercial grade to residential grade. But what it kind of goes back to that weeding through that cool factor thing. We really want to focus on, okay, you like that feature, you do it at your house, that's great. Now, is that going to be used by everyone? Is it going to pay back for you? Is it going to retain tenants? Or do you have a lot of tenants coming in and asking you, hey, I want to be able to do this? Then that starts to make the case for it. If it's like, no, I just like it, well, then, okay, maybe then let's do a high level budget. Let's budget it out for that building and see what it's actually going to take. And generally, when they start looking at some of the real numbers, they realize, okay, maybe it's not worth the money to put in that application, unless there's a very real measurable and way to evaluate that.
Perfect, thanks. It looks like you've got a question in the chat here. Do you have any thoughts on cross-compatibility between brands to allow the user to change if a company goes under or gets bought or discontinued?
Yeah, so this is where it comes down to looking at the communication protocol they're using right now. If I would say, Enotion it's a great little technology, but and everyone seems to be using it right now, but an Ocean as a protocol, it is a private company, and could it be something that would go under? Absolutely. I'd love to say that all the lighting controls manufacturers are all kind of planning to, make it so that one sensor can talk to a different manufacturer switch, kind of like your cell phone walks in, you walk into a space for free Wi-Fi, that your Wi-Fi radio is going to talk Wi-Fi because it's all standardized. There is a very big push, especially from the corporate level, of these people that are building these roadmaps in finding ways to do non-proprietary or limit the amount of proprietary nature of devices. So in terms of lighting controls devices, when we go to that diagram with the sensors going to the digital power packs, I don't know of a single manufacturer that is interoperable at that point. That digital power pack to devices, it is locked in. That's very proprietary. But beyond that is where it starts to open up, and can we find devices or something that can talk. As soon as you've got an Ethernet based device, then it is interoperable. That's something critical here. If some manufacturer comes to the table and says, hey, I've got an occupancy sensor that's Cat 6 right to a network switch and talks to the server, and it's standard Ethernet, well, now we definitely have an interoperable system. No one's there yet. I'd like to say we'll get there, but I really don't believe that manufacturers have found the value in that yet. So I think they're working. We'll see it happen, but it's happening on a more grand scale too, not just in lighting controls, but in all systems when we talk about these intelligent buildings, because they're all starting to realize that maybe they're kind of limiting themselves in their application if they're not interoperable.
Great. I see another one in here. With technology changing or updating to new operating systems every 2 to 3 years, how are you talking to the clients about the worries about lighting control becoming obsolete or out of date in a short period of time?
So I've even had conversations with some manufacturers about this, because a lot of R&D and time is being spent into these fancy user interfaces and softwares that the building operators don't want. And I think the key here is going back to the single pane of glass. The single pane of glass does not require a lighting control system to have a 3D floor plan, every device on there or anything like that. It requires that the data be free and available and usable by the head system or the single pane of glass system. So that's what we need to focus on, is those lighting control systems have free and accessible data that can be used by anyone. I know of one client, they've now kind of signed on with a company called Code Labs. If you're ever interested in looking, they're an interesting company, KODE. But their requirement, the client's requirement, was that I want to be able to unplug your system and plop a new system in without any hardship, without changing other hardware. You would have to, rewrite some of the APIs and the programming, but I want to be able to replace you essentially. And so these single pane of glass companies that are out there that are doing these main user interfaces, they're making themselves interoperable. They're making sure, and as long as the systems below it, whatever the system, including lighting control, uses API, that gives you that flexibility, and it means that anyone can talk to that API, and you're not going to hamstring them in terms of what they can do.
Great, thanks, Dave. We're getting close to the top of the hour here, so maybe I'll cut it off. But I think you had your email address on that last slide, if you don't mind sharing that again, just in case anybody on the call has more questions for you, I'm sure.
Absolutely. Anyone's feel free to reach out to me, and I'd be happy to help.
Great, perfect. Thanks, Dave. I appreciate it. I think it was a really good conversation and something that is very topical right now for sure.
Absolutely.
Couple of quick things about IES Edmonton. We're looking at starting to do a couple in-person events here in the coming months. So keep an eye out in your emails for an in-person lighting trivia event. We did an online one last year and we had a lot of fun, so we thought it could be even more fun if we do it in person. And also keep an eye out for our annual general meeting. Our AGM will be upcoming as well. It's April already, everybody. Crazy. So keep an eye out for that. And along with our AGM will be our local Northern Lighting Awards. So we'll be looking out for some submissions for that. Was there anything else, Lena, that you had on?
No, I think you covered it all. Just looking forward to actually seeing some people in person again. It's been a while since we've had an in-person event. So fingers crossed everything stays good and we can see a bunch of people out. And thanks again for a great presentation, Dave. There's a lot of interesting things to think about. I'm still processing. I'm sure I'll have questions at another point.
No, thanks for having me, guys. I appreciate it.
Great. Thanks, everyone. And thanks again to the Calgary section for joining as well. It's always a pleasure to have you guys on the call. So
thanks so much for having us. Appreciate you joining us, bringing us into it. So, and thanks, Dave. Always a pleasure.
Absolutely.
Great. Thanks, everyone. Have a great afternoon.
You too.